Hello and welcome to Aditya classes, where we have been learning these days inventory management. Now, in previous lectures we talked about various models of inventory, where mainly we had a purchase model and a manufacturing model. Purchase model is one where we place an order and immediately the inventory is replenished. Then manufacturing model is one where I give an order to my own department for certain number of units. Now, when I give an order to my department to produce certain number of units for me, then the inventory doesn't go up immediately. In purchase model, the inventory goes up immediately, while in manufacturing model, the inventory goes up with the production rate. Because I'll start my production, I'll produce 100 units in first hour, 100 units in second hour, 100 units in third hour. So, in the day itself, the inventory will rise slowly. And if you need 10,000 units, 1,000 units will be made on first day, 1,000 will be made on second day. So, inventory rises slowly. Whereas in purchase model, inventory rises immediately because the consignment arrives and you have your inventory. So, that was the basic difference between purchase model and manufacturing model. So, today what we'll do is, we'll start up with some questions and we'll try to identify that which model makes sense over here. If we have a recap, what were the four models that we talked of? Models of inventory management. What were the models? We had a purchase model, and a manufacturing model. Then this purchase model was without shortage and with shortage. Same was with manufacturing models. Without shortage and with shortage. So what we'll try and do is, we'll try and put up some questions over here and try to identify that which model makes sense over here. So our first question says, Alpha Industry estimates that it will sell 12,000 units of its product for the forthcoming year. 12,000 units for the forthcoming year. So one thing very important to notice in all these models is the time frame. The time frame for all different entities that we will be dealing with should be same. For example, we have a time frame for carrying cost also. Carrying cost is given in per unit per period. What is the carrying cost? Per unit that I will be spending per period. For example, if I am carrying a unit for 1 day, what will be the carrying cost? If I am carrying that same unit for 5 days, what will be the cost? So the carrying cost is given in per unit per period. Then demand is also given in period. So we need to make sure that both these things are on same time frame. The carrying cost also and the demand also. In this case, it is 12,000 units per year in forthcoming year. The ordering cost is rupees 100 per order and the carrying cost will be 20% of the purchase price. Ordering cost would be rupees 100 and the carrying cost would be 20% of the purchase price. This is the information that we have been provided with. The purchase price per unit. The purchase price per unit is rupees 50. So the idea is the demand in the forthcoming year will be 12,000 units. The ordering cost is rupees 100 per order and the carrying cost is 25% of the purchase price per unit. And because the period is not mentioned, so we'll assume it is also per year. Technically, the carrying cost should be per unit per period. Now, if they are saying only per unit, okay. So sorry, carrying cost they are saying per unit per year, 20% of the purchase price, fine. And the purchase price is 50 rupees. So 20% of the purchase price, that is 50 rupees, 20% of 50 rupees would be 10 rupees. So carrying cost is 10 rupees per unit per year. If you carry a unit for a year, it will cost you 10 rupees. And for placing an order, it costs me 100 rupees. Find EOQ, economic order quantity, number of orders per year and time between successive orders. Now the language can be different. This time they are asking for number of orders per year, time between successive order. Time between successive order can also be asked as cycle time. Cycle time is the time when our cycle is repeating, order cycle is being repeated. So it can also be called time between successive order, or it can also be called as cycle time. So let us go ahead and try and find out which model makes sense over here. Now if we make a quick recap of all the models. EOQ was equal to, let me call this first model, second model, third model and fourth model. Just for reference that which model it is, I'll just write down what are the different formula for EOQ. EOQ for first model. What was the EOQ for first model? It was under root of 2AO upon C. What was EOQ for second model? Second was with shortage. So in that case it becomes 2AO upon C multiplied by, there is an additional factor which is C plus S upon S. Then EOQ for third, which was manufacturing model without shortage. Manufacturing model without shortage, 2AO upon C. Now because it is manufacturing model and there is no mention of shortage, without shortage, so there will be no factor of shortage, but there will be a factor of 1 minus A by P. This will be for my manufacturing. This factor comes for manufacturing. And what will be the case with fourth? EOQ for fourth is under the root 2AO upon C, 1 upon 1 minus A upon P, and then there is C plus S upon S. So these are the EOQ or EBQ. And yes, it makes more sense if we call it EBQ. Instead of calling it EOQ, let us call it EBQ. Because these are manufacturing models. In manufacturing models, we do not have EOQ, rather we have EBQ. So these are the formulae. Now let us extract the information given in this question and then we'll see which is this particular model. Let us jot down that information. Demand is 12,000 units per year. Ordering cost is rupees 100 per order. Then carrying cost is 20% of purchase price per unit per year, making it 20% of 50, making it rupees 10 per unit per year. So we have A, O and C. This is all. Then there is purchase price also, which we made use of over here. Purchase price is rupees 50 per unit. This is all the information that has been provided to us, and now we need to find out which is this model. Now if we have a look at the information given, we see that we have been provided with A, O and C. When A, O and C are given, there is no mention of S, there is no mention of P. So if there is no S and no P, absence of S in the given information means that it is not a shortage model. It is for sure not a shortage model, because if it were a shortage model, the question should have provided me with shortage cost. So definitely this is not a shortage model. So these two models are out of equation. It cannot be the second model, it cannot be the fourth model, because ours is without shortage, because there is no mention of shortage. Then we have no mention of P also, production rate. So definitely this is not our manufacturing model also, because this has P also. So it is not shortage because there is no mention of S. It is not manufacturing because there is no mention of P. There is no P in this. This is purchase price. We need production rate. So it cannot be second model, it cannot be third model, it cannot not be fourth model, it can only be first model, which is purchase model without shortage. Now if we try to recap what was the purchase model without recap. Now whenever I draw this graph, students always ask, is it necessary to draw the graph? So it is not necessary to draw the graph, but the idea is that, not inventory, let us call it quantity. But the idea behind plotting this graph is that we come to know what are various parameters related to this model. What are various parameters related to this model? If you remember the previous lecture, we had so many parameters. We had a T, T1, T2, T3, T4. Then we had a Q, Q1, Q2, EBQ, EOQ. So there are so many values. What are relevant parameters for this model? What are relevant parameters for this model? One thing that we get from here is that only T is a relevant parameter. There is no T1, no T2. And if you remember this model clearly, then we have Q is equal to Q1 is equal to EOQ. So these are the relevant parameters for this model. EOQ is the order quantity, Q is the swing in inventory, the change in inventory level, Q1 is maximum inventory. All these three things are equal in our very first model, that is purchase model without shortage. This you can see check out in the previous lecture where we actually talked about all these models. So these are the parameters that we need to find out. Yes, as far as the question is concerned, they are interested in knowing the EOQ, they are interested in knowing number of orders, and then they are finally asking us to find out time between orders. Time between orders. So this is all the information extracted from the question. This is the applicable model. We have identified why it is this model, because it cannot be shortage model, it cannot be production model, manufacturing model, it has to be this model, EOQ1. Now can we go ahead and find out these values? EOQ is equal to Q1 is equal to Q. EOQ is equal to under the root 2AO upon C, making it under the root 2AO upon C. How much this will be? It will be 2 multiplied by 12,000 multiplied by under the root 489.89. 489.89. So this is our first answer. EOQ is 489.89. Then it is number of orders. Number of orders. How much? Number of orders. The formula for number of orders is A upon EOQ. So in this case it becomes 12,000 divided by 489.89. Why this formula? If we try to understand this formula, if you have a demand of 1000 units and you order 100 units each time, so how many orders do I need to place? 10 orders. It is as simple as that. If I have a demand of 1000 units and I place an order of 100 units each time, I have to place 10 orders. If I have a demand of 1000 units and I place an order of 250 each time, I'll have to place 4 orders. So this is your demand, this is your order size. 1000 is your demand and 100 is your order size. 1000 is your demand, but this time your order size is 250. So number of orders is A upon EOQ. So in this case it becomes how much? We have 12,000 divided by 489.89. It becomes 24.49. 24.49 orders per year. I'll have to send 24.49 orders in a year so that I can have my 12,000 units which I require to sell. The demand is 12,000 units. Then our third issue is time between orders. Time between orders. Now, if we have a look at this formula, this formula is EOQ upon A, making it 489.89 upon 12,000, making it 489.89 divided by 12,000. This comes out as 0.040824166 years. Time between orders is 0.048244166 years. Now, does that make sense? If I were a production manager and I asked my stores to place an order every 0.040824166 years, if I asked them to place an order every these many years, would they be able to interpret what I was telling them? They won't be able to interpret what is this many years. I can understand half a year, I can understand quarter of a year, I can understand 1 year, I can understand 10 years. What is this 0.0408 years? So what I'll do is, I'll multiply this thing to 365. If I multiply these years to 365, they'll get converted into days. Let us see what happens. It comes out as 14.90 days. Now it makes sense. So you can leave your answer in years also, but it is logical to convert it into days. Now, if I were a production manager and I would ask my store to place an order every 14.9 days, they would understand. Every 14.9 days would mean every 15th day, by the end of every 15th day. So these are the three values that were desired in this question. We have all these three values. And how did we identify which model it was? We identified from EOQ1, EOQ2, EBQ3, EBQ4. Because there was no mention of shortage, 2 and 4 were not possible. Because there was no mention of production rate, 3 and 4 were not possible. So ultimately I was left with only one model. This was our very first model, which is purchase model without shortage. So for our next question, the values are given directly. So we'll use them directly. The values go like this. There is a demand of 24,000 units per year. There is a production capacity of 48,000 units per year. Then there is an ordering cost of 200 per setup. The setup cost is 200 per setup and carrying cost is rupees 20 per unit per year. Rupees, okay, this is also in rupees. Rupees 20 per unit per year. So now, this is the model, this is the question that has been given to us, and they are saying find all relevant parameters. Find all relevant parameters. So this is the question that has been asked. This is the information that has been shared with us. Fine. Now, what model can this be? We have AOC, so obviously it is some of these models. There is no mention of shortage, so it cannot be second model, it cannot be fourth model. There is no S in this, but there is a production rate. So when we have production rate, it can either be this model or this model. It can definitely not be, because these two are not making use of P. There is no production rate in this, there is no production rate in this. So when we have P, it cannot be these two models, it can only be these two models. Because we have no shortage cost, it cannot be second and fourth model. So now from this analysis, what do we see? We see that our question comes from third model. What is our third model? It is manufacturing model without shortage. There is no shortage, but there is production rate. No shortage meaning these two are gone. There is a production rate meaning out of these two. So I zero in on third model. So my model is third one. Now, as I said in previous question also, that we should always plot the diagram. We should always make the diagram so that we know what are the relevant parameters, because they are asking for relevant parameters this time. So what are all the relevant parameters? This is only one formula for EOQ or EBQ. But then there could be a Q1, Q2, there could be Q, there could be T1, T2, T3, T4, T. So what are all relevant parameters for my particular model? What is my model? My model is manufacturing model without shortage. Now, if you remember, manufacturing models have this kind of shape. They do not get instantaneous replenishment, rather they climb with some rate. They increase. And what is the rate of increase? It is P minus A, if you remember the previous lectures. And then they start going down. After they have reached a particular inventory level, they start going down. And when they go down with the rate of A. So once again, here we have our quantity, then we have time, and now this time if I see, I have a cycle time, and also I can see that I have T1 and T2. So in previous question, we were only having T, cycle time. There was no T1, T2 because there was instantaneous replenishment. Instantaneous replenishment means you get your inventory immediately. So there is no going up phase. Increasing phase is absent. There is instantaneous replenishment. So T1 is almost 0, as good as 0. And if T1 is 0, then T2 becomes equal to T. So in previous model, we had only T. There was no T1, there was no mention of T2. But in this case, we will be having T1 and T2. Also, what is this? Is this Q1 or EBQ or Q2? What is this? This is Q1 is equal to Q. Q1 is positive inventory. Q is swing in inventory. Q1 is maximum inventory that we'll be having, maximum positive inventory that we'll be having. So, and Q is swing in inventory. Swing in inventory is from minimum level to maximum level. So, in this model, Q1 and Q are same. Again, I would suggest you should watch the previous two videos, previous three in fact. In one lecture, we talked about purchase models. In another one, we talked about manufacturing models. And then there was a third one where we combined all of these four models to compare them. So, I would suggest you go through those three videos also, so that we have a good know-how about T1, T2, T, what are these various times, what are these various quantities. In any case, here we have Q1, Q and all these things. Now, should we start with EBQ? EBQ as it is we have over here. We have our manufacturing model without shortage. So, EBQ we already have. What about Q1? Formula for Q1 is 2AO upon C 1 minus A by P, and then there is a factor of shortage also, C plus S. Sorry, this is not a shortage model. Sorry. This is not a shortage model. So, this will be our formula. Manufacturing without shortage. And because it is manufacturing, we have a production rate also. So, we have EBQ, we have Q1, and incidentally Q will be equal to Q1, there is no Q2. What about T? T forever is EOQ upon A. T1, the quantity consumed in time T1. T1 is this and quantity is Q. Quantity consumed, not quantity consumed, rather it will be quantity under question. So, the quantity is Q1. And what is the rate of going up? Rate of going up is always P minus A. Then what is T2? It is again T2. The swing in quantity is from Q1 down to 0. So, again it is Q1, but this time we are coming down with the rate of A. So in both T1 and T2, the quantity is Q1. In first case for T1, we rose from 0 to Q1. In case of T2, we came down from Q1 to 0. So either ways, the swing is Q1. But yes, while going up during T1, the rate was P minus A. While coming down, the rate is Q1. The rate is A. T, if you remember previous questions, previous lectures, T is always order quantity upon demand. So EUQ upon demand. So whatever is the quantity upon rate, quantity upon rate, quantity upon rate. A is the annual demand. So annual demand is the rate of consumption, the rate through which we are consuming. So these are the formulae. Let us go ahead and find out all these values. First of all, we will be having EBQ. What will be the EBQ? Formula would be 2AO upon C multiplied by 1 upon 1 minus A by P, making it 2. A is 24,000. O is ordering cost or setup cost. Now, because this is a manufacturing model, it is better to call it setup cost. Instead of calling it ordering cost, we call it setup cost. Because we are not placing an order with someone else. We are not spending money on placing an order outwards. The the material is not coming from outwards. So there is no transportation, there is no order placing. Rather, it is an internal affair. I am placing an order with my own department. And that department will set up the production process. So we do not call it ordering cost, rather we call it setup cost. Because they will be arranging how we should be producing. They will be bringing up the temperatures of the machines. They will be bringing up the temperatures of the chemicals. They will be working on a setup. So whatever is spent during that setup is called setup cost. And in case of purchase models, this is known as ordering cost because we place an order outwards. Someone will go there, some taxi will carry it, carrier will carry it. So it is setup cost in this case, ordering cost in purchase model. So we have 200, then carrying cost is explicitly given as rupees 20. Remember, the time frame should be same. It is per year, per year. If it were something else, for example, if it were quarter, 5 rupees per quarter. So if it is in quarter, I need to convert it into year. 5 rupees per quarter means there are 4 quarters. So it will be 20 rupees per year. These times should be same, year. So this is 2AO upon C, then there is a factor of 1 minus A by P. 1 upon 1 minus 24,000 upon 48,000. If we go ahead and solve it, we get 2 multiplied by 24,000 multiplied by 4,80,000 is this first factor, 4,80,000. Second factor would be 1 upon 1 minus 0.5, making it 4,80,000 multiplied by this will be 0.5, 1 upon 0.5, 4,80,000 multiplied by 2, 9,60,000, which comes out as 979.79. 979.79. So these are all relevant parameters. EBQ, of course, I have not written it over here, but there is EBQ. So this is EBQ. Then there is Q1, Q, T, T1, T2. Next would be on the list Q1. Q1 is under the root 2AO upon C, and this factor gets reciprocaled. 1 minus A by P. 1 minus A by P. So the values would be 2AO upon C. With this factor, this time instead of denominator coming up to numerator 24,000 upon 48,000, making it, once again this factor would become 4,80,000 and this factor would be 1 minus 0.5, making it 0.5. This was 0.5. Okay, so this is 0.5, making it under the root 2,40,000. What will be the value? 2,40,000 under the root 489.89. 489.89. So, EBQ is almost 980 units, but my Q1, that is the swing in inventory, that is the maximum inventory, is 490, almost 490. So, we have EBQ, we have Q1, remaining is T, T1 and T2. What is formula for T? Formula for T would be EBQ upon A. EBQ is 979.79 upon A, which was 24,000. This will be EBQ. Because we are in manufacturing model, so it is better to write it as EBQ. How much is this? Divided by 24,000 gives me 0.040824 years. Again, it is better you multiply it to 365 to get how many days? 0.040824 multiplied by 365. It is 14.9 days. 14.90 days. So, time between order. If we wish, we can call it time between orders. If we wish, we can call it cycle time. Either ways, it is 14.9 days. What about T1? Formula for T1 is Q1 upon P minus A, making it Q1. Q1 is 489.89. 489.89 upon P minus A, that is 48,000 minus 24,000. Making it 489.89 upon 24,000. This will be 489.89 divided by 24,000. 0.0204 years. And if I multiply it to 365, it gives me 7.45 days. 7.45 days. And finally, can I have my T2? T2 would be again Q1 upon A, making it 489.89 upon A, 24,000. So, either ways, this was 48 minus 24 giving me 24. This time it is directly A, so it is again 24. So, again I will be getting it as 0.0204 years or 7.45 days. Now see, this is a very good checkpoint for us to see if we have calculated everything properly or not. Now suppose if we make some error in EBQ or if we make some error in Q1, it will always get reflected over here. T1 and T2. T1 plus T2 should give me T. T1 is 7.45, T2 is 7.45. If I add them, they should be 14.9 and my T was 14.9. So, it is always a very good idea to add your T1, T2, T3, T4s to get T. If they are perfectly adding, like in this case 14.9, 14.9, then definitely EOQ and Q1 have been found out correctly. Because there is a chance that we might mess it up somewhere. Because we are making so many calculations, there is a high likelihood that we may make some error. So you can always be assured by adding the different periods of my complete cycle. Adding T1, T2, I should get T. In this case, I'll be having T1, T2, T3, T4. If I add all those 4, I should get T. So this is the idea behind this. So we have gone through the first model, we have gone through the third model. Purchase model without shortage, manufacturing model without shortage. So we'll close this lecture over here and we'll continue with our second and fourth model in the next lecture. So this is it for our present discussion. Until we meet for next discussion, do take care. Thanks for watching. Bye-bye.